Welcome to Unit 5. In this unit, we are now going to begin to bridge away from linear equations, and we are going to start bringing in nonlinear equations. Now, this unit isn't directly about nonlinear equations specifically, but this unit is the bridge unit. So what I mean by that is the first half of this course was all about linear equations and things like order of operations. Now we are going to begin to bridge away from linear equations, and for the second half of the course, it's going to be emphasized on nonlinear equations. But before we do that, we have to talk about a couple things, and that is some exponent rules and how to deal with square roots. So in this unit, we're going to deal more with exponents and how to do operations like PEMDAS, order of operations, but with square roots. So that's what you get to look forward to in this unit. So our first topic is all about the basics of exponents. So here are the following rules that is going to be useful in this section. So I call this the zero rule, which means that if you have anything raised to the zero power, it always equals 1. So it doesn't matter what's raised to the 0th power. It can be a number, it can be a variable, or anything really. Anything just raised to the 0th power always equals 1. So that's an easy rule there. For the second rule here, we have the product rule, which states that if you have x to the a times x to the b, this ends up equaling x, which is the base, and you just end up adding the exponents a and b together. And then here we have what's called the power rule, which means if you have something x to the a and all that being raised to the b power, you end up just taking x and multiplying a and b together. And then our last rule we're going to talk about in this section is called the quotient rule, which means if you have x to the a divided by x to the b, you just take x and subtract the exponents. And that's our exponent rules. And then our last thing I want to talk about before diving into some examples, we're going to talk about like terms. And recall that terms are parts of an expression or equation that are separated by addition or subtraction. Now, if you have terms with variables, which recall, variables means letters. So if you have terms with variables that have the same exponent and same base, you can add or subtract those terms together. So below, I'm going to show you what a base is and what like terms may look like with exponents. So let's see here. So let's say we had 3x squared plus x, let's say we had 3x squared plus x squared. Now, do we think we could add these two? Do we think we could add 3x squared and x squared together? Yes, you can. And here's why. And that is because we have the same base, which is x. So we have the x terms, or the x means we have the same base. And because both of these x's, or both of the bases, are squared the same exponent, we can combine them together. Sorry, it's kind of a tight squeeze, but so 3x squared plus x squared equals 4x squared, and that's it. Now looking at our second example, example 2, we have 2x plus 3y squared. Do we think we could, 2x squared plus 3y squared. Could we add these two together? We can't. And that is because we have different bases. We have an x base and a y base. So these two are different bases. But we do have the same exponents. Our exponents are both raised to the second power, but because we have different bases, we can't simplify this at all or combine any like terms. So this is our answer, 2x squared plus 3y squared. And that's it. So now that we've got a little bit of practice with it, let's just dive right into the examples of this section. So in the following examples, use the exponent rules mentioned above to simplify the following expressions. So for number 1, we have 3 squared plus 3 squared times 3 cubed. Now, I know what you're thinking. I can just use order of operations for this. You can, you're not wrong. But here's the thing. We're in these examples, let's use these exponent rules, and I'm going to tell you why. Because in the next page, you're going to be doing exponent rules with variables, and you can't necessarily simplify y squared on its own. You're going to need to use exponent rules for that. So let's start using exponent rules right now, so then that way you can get the flow of it and see how it works. So we have 3 squared times 3 cubed. While using these exponent rules, we can use the product rule here because we have the same base, 3 and 3. So all we need to do is add the exponents together. So what this looks like is we're going to have 3, the base, and then we're going to have 2, the first exponent, and then we're going to add that second exponent. So we have 3 raised to the 2 plus 3 power. Now 2 plus 3, that just equals 5. So we have 3 to the 5th power. And if you wanted to evaluate 3 to the 5th power, you'd get 243. That's your answer. Looking at example number 2, we have 3 squared times 3, or 3 squared raised to the 3rd power. So I encourage you to actually pause the video and see if you can figure this one out on your own. And assuming you've given it a go, let's go through it. So we have 3. Now let's look at our exponent rules. In this case, we're going to use the power rule, which states that we need to multiply the exponents together. So we're going to have 3 raised to the 2nd power, or 3 raised to 2 times 3. So what that's going to be? Well, that's going to be 3, and then 2 times 3 is 6, and 3 to the 6th power evaluates to 729. Looking at example 3, we have 3 cubed divided by 3 squared. Now looking at our exponent rules, I'm going to use the quotient rule here because we have the same base being divided by 2 separate exponents. So let's do that. So we're going to have 3 raised to 3 minus 2. Now 3 minus 2, that's just 1, so we get 3 to the 1 power. Well, 3 to the 1 power means we just multiply, or that just means that 3 is on its own, right? So this just equals 3. So anytime you have anything raised to the 1st power, that's just itself. And that's your answer. Looking at example 4, we have x cubed times x to the 4th power. Now, how are we going to do this? Well, we're going to take x, and then because we're multiplying these, this is going to involve the product rule, which recall that states that we need to add the exponents together. So we're going to have x to the 3rd power, or x raised to 3 plus 4. What's 3 plus 4? That's 7, and we can't simplify x to the 7th anymore, so that's your final answer. Looking at example 5, I encourage you to pause the video and work through this together. And assuming you've given it a go, let's go through this. So for example 5, we have 3z to the 8th power, all divided by 3z cubed. So the first thing what I'm going to do here is I'm going to break apart this division problem into 2 separate problems. So I'm going to first divide the integers. So that's going to be 3 divided by 3. And then I'm going to multiply that by what this happens to be. So since we're dividing this, recall the quotient rule states that we subtract our exponents. So we're going to take z and raise that to 8 minus 3. So 3 divided by 3, that's just 1. And then we're going to multiply that by z. And then 8 minus 3 is 5. And 1 times z to the 5th, well, that's just z to the 5th. So that's your final answer. Looking at example number 6, we have y squared all raised to the 0th power. So I encourage you to pause the video and try this one on your own. And assuming you've worked through this problem, let's go through this together. So recall, this problem is going to use that power rule where you multiply the exponents. So we're going to get y raised to 2 times 0. Well, 2 times 0 is just 0. And recall, we have this thing called the 0 rule, which states that anything raised to the 0 power equals 1. So that's your final answer. All right. So looking at example number 7, we have 3y squared times 2y cubed plus 4y to the 7th power divided by 2y squared. So to solve this, I'm going to multiply these two expressions, or these two terms together. And then I'm also going to simplify this as well at the same time. So let's do this first. So we have 3 times 2, which is 6. And then y squared times y cubed, well, that becomes y raised to 2 plus 3. Because we're dealing with the product rule, because we're multiplying. And then I'm going to add this expression here, which we're going to do 4 divided by 2, which is 2. And then we're going to multiply that by y raised to the 7th power minus 2. Now to simplify this, 2 plus 3 is 5, so we're going to get 6 y raised to the 5th power. And then we're going to add 2y. 7 minus 2 is 5. Now can we simplify this anymore? We can, and here's why. Because we have the same base, we have y, so we have the same base here, and we have the same exponent. So we're going to do 6 plus 2, which is 8, and then we're just going to carry along y to the 5th power. And that's your final answer. Now that you've seen some examples, I encourage you to pause the video and try examples 8 and 9 on your own. And then once you have done these, you can go ahead and resume the video and we'll go through these together. And if you can get these problems correct, you're really set to go for your exponent rules. Alrighty, so assuming you have given these an attempt, let's go through this. So for example number 8, we have 8v to the 7th power divided by 4v to the 0th power minus v to the 6th plus v to the 7th power. Okay, so looking at this, I want to first simplify this expression here, this fraction. So how I'm going to do that? Well, I'm going to first divide 8 by 4, which 8 divided by 4 is 2. And I'm going to take that variable v, and I'm going to do 7 minus 0. And then I'm going to subtract v to the 6th power plus v to the 7th power. Now 7 minus 0, well, that's just 7. So we get 2v to the 7th power minus v to the 6th power plus v to the 7th power. Well, let's see what we can combine here. Well, we can combine this 2v to the 7th power and this v to the 7th power because they are like terms. So let's do that. So we end up getting 2v to the 7th power plus v to the 7th power is 3. V to the 7th power. And then this v to the 6th power, we can't combine it or do anything with it, so that's just going to come along. And that's your final answer. Looking at example number 9, we have 2x squared times 4x plus 2x all raised to the third power. So looking at this, the first thing, well, we can actually do two things at a time. So when things are separated by addition, you can, whatever's separated by addition, I like to call these islands. So this is an island and this is an island. That's separated by this addition symbol. So since this is separated by this addition symbol, I can simplify this and this at the same time. Just kind of like how I did this problem. So I simplified these two, this product and this quotient at the same time, all in one step. And then I end up adding them together. So that's what we're going to do here. So 2x squared times 4x. Well, 2 times 4 is 8. And then, because we have a product here, we're going to use that product rule that states we add our exponents. So we're going to get x squared plus, and then this 4x has an invisible exponent of 1. So we're going to get 2 plus 1 here. And then we're going to add 2x all raised to the third power. So because this whole thing is being raised by the third power, I'm going to have to distribute in that third power to both the 2 and the x. So we're going to get 2 cubed times x cubed. So to simplify this a little bit more, we have 8x to the 2 plus 1, that's x cubed. And then we're going to add 2 cubed is 8. And then we're going to carry along the x cubed. And we can add these two terms together because they both have a common base of x and the same exponent of 3. So 8 plus 8 is 16. And then we're just going to carry along that x cubed. And that's your final answer.